So hello everyone, let us solve another LeetCode problem, and the problem name is last day where you can still cross. So let us read the problem first. So there is a 1 based binary matrix where 0 represents land and 1 represents water. So this time it is not a 0 based indexing, it is 1 based indexing matrix where 0 represents land and 1 represents water. Now you are given integers row and column representing the number of rows and columns in the matrix there are. So after that, initially on day 0 the entire matrix is land. So on day 0, let's say this is the matrix, so entire thing is land, that means entire thing is 0. So however, each day a new cell becomes flooded with water. So you are given a 1 base 2D array cells where cells of I equal to Ri comma cell I represents that on day I the cell on the rth row, R of ith row and C of ith column in 1 base coordinates will be covered with water, that is changed to 1. So let's say there is some cells like array or vector given. So on each indexing or on each day there is some row and column value given. So let's say in this 1 comma 2 is given. So this is the indexing 1 comma 2 1 comma 2. So let's say this is the day 1. So on day 1 1 comma 2 becomes flooded with water. So 1 comma 2 is this, so it will be changed to 1. So on and so forth. So there will be various like cell values be given. So for each day one of the cell will become flooded with water. Now what is your task is, you want to find the last day that is possible to walk from top to bottom by only walking on land cells. So you can start from any cell in the top row and end at any cell in the bottom row. You can only travel in 4 directions, that is top, right, left and down and left. And in the end you need to return the last day where it is possible to walk from the top to the bottom by only walking on the land cell. So what the question is saying, let us understand with the help of first example. So your main aim is to reach from top row to bottom row. So you can start with any cell in the top row and you need to reach at any cell in the bottom row. So in this case this is let's say day 0, this is day 1, this is day 2 and this is day 3. On day 0 everything will be land cell, so you can simply walk across the top row and bottom row by any way, like this or like this. On the day 1 you can see 1 comma 1 becomes flooded with water. So this is the indexing, let me just mark it 1 2 1 and 2. So on day 1 1 comma 1 is flooded with water, so this becomes flooded with water. Now you cannot step onto this particular cell, but still we can choose this cell in the top row and we can go down like this to reach the bottom cell in the bottom row. Then comes the day 2. On day 2 you can see that 2 comma 1 becomes flooded with water. So 2 comma 1 is this, so this becomes flooded with water. So still we can go from top row to bottom row easily like this. On day 3 1 comma 2 becomes flooded with water. So 1 comma 2 is this. So now your top row is entirely flooded with water, so you cannot step on any cell in the top row. Now if you can't step on any cell in the top row, how you can reach from top row to bottom row? So what is the minimum day that what is the last possible day where we were able to cross the top row to bottom row? So this was day 2, because after this in this we are not possible to go from top row to bottom row, so this is not possible. This was the last day where it was possible to do so, so we would be returning 2, so that's why the output is 2. So this is the problem statement. Now this looks easy to understand, and if you write the brute force approach it is pretty much simple. Like what you can do, for each day you can just mark the particular cell to be water, and you can try out each and every cell in the top row and just apply DFS or BFS to explore all the paths. Now after trying out all the possibilities, you can simply say whether or not I am able to reach by any possible scenario from top row to bottom row or not. if it was possible, you will update your answer, and in the end whatever the last answer you get, you will be returning that, because that would be the least possible day. So the brute force is pretty much simple: explore all the paths. So how can we do the brute force approach? Let us see with this example only. Like, this is the first scenario where 1 comma 1 is the like flooded with water. So you mark this as flooded with water, you try out all possibilities. Now in this case there is only one cell, but let's say there were many more cells as well, let's say like this. So you would be trying this, starting from this particular cell, you would be trying to start with this particular cell and then this particular cell. You will be applying DFS with each and every cell. Okay, this is done. Now you come across the day 2, you again like change it to flooded with water. Now again you would be starting from the top row, each and everything, and you would apply DFS and do same thing again and again. But if you apply the brute force approach, it would give you TLE in this case. So we cannot write the brute force approach. So how can we optimize this solution? Now there is one very interesting observation, if you would notice. So let me just write this particular example to make you understand what is the observation. So yes, I have just written the cell values for the example 1. So this was example 1. Now what is the observation? Now let me just now just tell me whether, if this is the particular cell where you are not able to reach from top row to bottom row, this is the cell. So will you be able to cross in these further row, further like processes? Now if you, at this position you are not able to go from top row to bottom row, by no way you can say that okay, there is a chance that I can reach top row to bottom row by flooding this, because this will make the condition worse only. So can't we say that we are breaking something after trying particular scenario? Like, we are just eliminating this part, we are trying on to this part only, right? This is what we are doing. And can you say that okay, this is the cells value given? So let me just rewrite this again: 1 comma 1, 2 comma 1, 1 comma 2, and 2 comma 2. So let's say this is the part where you can reach from top row to bottom row. Now if you are able to reach top row to bottom row, will you not explore further days? Like, what can be the more days where you can reach top row to bottom row? Yes, you will go towards the right to explore what is the like last day where you can cross. So you would try to search in this particular part. Now if you try to search in this particular part, let's say you come across this cell. Now you get to know that okay, this is not possible. This cell, if you flood it with water, it is not possible to like cross from top row to bottom row. So you will not again further search in this. So at this position you are eliminating the right part. If you are able to find, you are exploring more parts. Like, you are not going towards the left, you are going towards the right. And if you are not able to process it at any point, you are not going towards the right, you are going towards the left. So what is this? This is nothing but binary search, right? This gives the idea of binary search. You can apply the binary search. Now how you can apply the binary search, how you can think in terms of binary search, let me just rewrite this again and I'll explain you. So yes, this is the first example again. So this will be your initially low value and this will be the high value. And for now I am taking zero based indexing. I will convert everything to zero based indexing. So let us like dry run on, not dry run, let us understand in this zero based indexing only. So 0 plus 3 by 2, that is 3 by 2 equal to 1. So our mid value will be here. Now you will check for this particular mid value. You will, what you can do, whatever values, whatever cells are there from 0th index to mid index, you will flood them with water. So what you will do, let me just write the process. So from 0 to mid value, what you will do, flood all the cells. because you are directly checking the mid part, so you need to do what all things that you have already done previously. So what you can do previously, you can just flood the values, nothing else. So if you are checking a particular mid value, just flood everything before it, then only you will be able to process it correctly. So from 0 to mid, first flood all the cells that are present. Now after flooding, you can just try out each and every possible scenario that you were doing in the brute force approach. Then what you need to do, so this is the first step. Second step would be what? Try out each cell from the first row. Like what could be the starting point in the first row, or what could be the starting cell in the first row from where you can get a correct part till the bottom row. So try out each cell from the first row, then explore using BFS or DFS, then explore using DFS or BFS. Okay, so this is the second point that we need to run. So what I am saying is that now this is the, like, what was that day? That day is day 2:1. Okay, so at this particular point we are currently at, so we have flooded everything with that were previously from 0 to mid, we have flooded everything with water. Okay, now let's say in this case there is only one cell, let's say there were 3 more cells. So what you will do, you would try to start at this particular top row cell, and you will, with the help of DFS, you would be exploring all the path. If you get the answer, well and good, otherwise you would be taking this cell as the starting point and you'll again do the DFS part like this. Now again, if you got the answer, well and good, otherwise you would start from this, then this, and so on and so forth. So this is what you will be doing. Now what is there is one more thing, that you need to mark all these cells visited, right? So we'll not be taking a visited array. Instead what we are doing, every cell we visit in the grid, we will just mark that particular cell to be one, that is flooded only. We don't actually need to mark any cell unvisited, because there is no point. Let's say you, like, there is some scenario like this. I'm just taking a random example. So you go from here to here, you mark this cell visited, you mark this cell visited. Now at this point you are not able to reach the bottom row by any means. Okay, so in this case you will be returning and you will be starting from this. Now at this point, if you reach this cell, now you don't want to explore this part, because this is already, we have seen that by coming on to this cell there is no part to the bottom row, so you don't mark this cell unvisited. So that's why instead of taking visited row, you can simply take you can simply update your grid of I, j from 0 to 1, and you won't change it to 0 again, because there is no point. Because if you are saying that there is no path from I to j to the bottom row, so there is no, like, it makes no sense to mark this cell unvisited again, because you will again mark it visited, you will again explore all this part, and you will again get the same result, like you cannot go to the bottom row. So instead of making the cell unvisited, you will keep that part visited, so that we can know, okay, this is visited and there is no path available. Okay, so this is how you will be doing. Now this was the second step of the DFS part. So you explored each and everything. Now there can be 2 scenarios. Either you get your answer or you do not get your answer. So in the third step you will be deciding, so if you get your answer or not. So if it is possible, what is possible? Possible means it is able to reach from top row to bottom row. So if it is possible, so what you can do? So if this thing is possible, so with this particular mid value, if it is possible to reach the top, from top row to bottom row, so okay, this is fine. This might be the last day, this might not be the last day. So for that, what we can do, we can explore in the right half. So what we will do, we'll update our low pointer to mid +1. Also we will update our answer. So we will what we can do, we'll keeping our answer, which would be storing the last day. So because this, we can't say anything, this mid might be the last day or might not be the last day. So we will be storing answer as mid plus 1 and then explore the right half. Now why we are doing mid plus 1? Because we are taking 0 base indexing and days are given in 1 base indexing. So that's why we are doing plus 1 to each and every mid value. So yes, now if it is not possible, then simply shift your high pointer to mid minus 1. So this example, let's say your mid value is here, just taking a random example, not on the basis of these current low and high values. Now let's say this is your current mid value and you get to know that okay, at this point we are not able to go from top row to bottom row, so there is no point in searching towards the right, so we will now search towards left. So to search towards left, what you can do, you can just set your high pointer to mid minus 1. So this is what we will be doing. So if it is not possible, set high pointer to mid minus 1, and in the end whatever answer you get, simply return the answer. So this is it about the problem the understanding of the problem. Now this problem is actually marked hard, but with the help of simple binary search like observation, like this question is actually in the medium range, because there are lot more questions that are harder than this kind of scenario. So this is, I think, actually a medium problem. With just simple binary search logic we can solve it. I think they have marked hard because there is multiple things, DFS plus binary search, so that's why maybe they have marked it hard, but like logic wise this problem would be, I think, medium rated. So this was it about the problem. Let us see the code now, how we can code this thing entirely. So this is the code. So first we are initializing the low and high pointer, low pointer to 0 and high pointer to cells.size minus 1, because we are applying binary search on the cells array or the cells vector. Let us take the answer variable as initially minus 1. Now I don't think there is a case of minus 1, but still let us initialize it with minus 1. Now we will be applying binary search while low is less than equal to high. So first what we will be doing, first we will be calculating the mid value like this, low plus high divided by 2. Then we are creating the grid. What grid? Grid of land and water. Let's say this is like this. Initially everything will be 0. Yes, like this. Now what was the first step? First step was to mark from 0 to mid each and every cell that we have come so far as flooded with water. So you'll just iterate from 0 to mid and take each and every cell that is present and mark that particular cell as 1. 1 means flooded with water. Now why we are doing minus 1 here? Just to take 0 base indexing. I have done everything in the 0 base indexing. You can do it in 1 base indexing as well. Then we are taking a boolean variable possible, which will be initialized to false in that explanation part that I have shown you, if it is possible or not. So this is the same variable which will tell whether it is possible with this particular mid value to reach from top row to bottom row or not. So then we are applying the DFS thing. Now for each and every column in the first row, we are trying out each and every possible scenario. So we'll be starting in the top row, right? So we'll be taking each and every column. So we'll be trying to do DFS with 0th row and 0th column. We'll be trying to do DFS with 0th row and first column. We'll try to explore path with DFS using 0th row and second column. So this is what we are doing. We are iterating on the column for the 0th row. So that's why I have written this 0 here. So if this grid of 0, j, that is row, col for the top row, if it is 0, that means we can explore the path because it is land. So if it is land, explore the paths using DFS. Now the DFS code is simple, nothing much to explain in this. I'll explain it in later. For now, let us understand. So if this DFS value returns true, that means it is possible to go from top row to bottom row with this particular 0, jth cell. So we'll mark your possible to be true, and now you don't need to check the other cells, because then it would be again nothing but the kind of brute force approach only, not exactly brute force, but yeah. So we are just breaking it from here, because now you don't need to explore the other columns which are land. So that's why we are breaking it. Now in the end we are checking if it is possible to go from top row to bottom row or not, whether this possible value is turned from false to true or not. If it is, just update your answer from to mid plus 1, because we are taking 0 based indexing, but we need to return answer on basis of 1 based indexing. So this will be storing on what day we were able to cross top row to bottom row. And if it is possible, you will try to explore in the right part. So you will go from low equal to mid plus 1. Otherwise, if it is not possible, you will try to search in the left half. So for that you are doing high equal to mid minus 1. In the end, you are just returning the answer whatever the last day you get. Now what is there in the DFS function? Let us see. The DFS is pretty much simple. This is the standard direction vector that we create to go from each and every cell, top, right, bottom and left. So this is the base condition. Whether we go out of bound, return false, or whether we go on to any of the the water cells, return false. If we reach the end row, the bottom row, then we have successfully reached our destination, so return true. Now explore the other paths in all 4 directions. Now before exploring, just mark the current cell as water or visited, one and the same thing in our scenario. So after marking this cell as visited, explore all the paths by going onto the top, right, bottom and left. So there will be new x and y coordinates based on this direction vector that we have created. Now after getting the new coordinates, again explore the path, and in any of the path you are able to reach the bottom row, simply return true. Now after trying out each and every possible path, if you are not able to get the answer, or if you are not able to reach the bottom row, simply return false. So this is what we are doing in this problem. So I hope you understand this solution. Thank you for watching.